iterations on on um, on your data so you understand it better itself. So what I'm going to talk about, and this all takes a bit of a minor code change, right? As you see. So what we created, what is Rapids itself? Rapids itself, the platform, is actually a collection of libraries that are analog to your favorite PyData libraries. So cuDF is analog to pandas. QML is analog to scikit-learn. QGraph is analog mostly to NetworkX. They have other libraries that they also overlap with for graph analytics. QVS is now doing vector search, and we have QSpatials, which is analog to GeoPandas. And we also have a visualization library, which allows for a new dimension in the ways that you can actually interact with your data. And if you need to scale out, well, we also use Dask, which, as you may know, is what's used to scale out pandas usually. And all of that connects to Apache Arrow with a GPU memory, and it can go back and forth between your favorite libraries. So much so, and this only takes a single line of code change normally. This slide I'm including in here because this is normally what it takes to run Rapids native. You're running pandas, you change from pandas, you run cuDF. cuDF itself has about a 60% API similarity to pandas. It's actually, of the pandas like libraries, it's got the most coverage of them all. We also have Spark, which, as you can see, we're just adding in Spark Rapids. From scikit-learn, we just change scikit-learn to QML. And from NetworkX, as NX, we just import QGraph. I normally pause here, but there's something else that just happened recently, which is that we have started to actually partner with our open source brothers and sisters, and we now allow you with zero code change to use pandas and accelerate pandas by up to 150 times faster, where your 4 or 5 minute joins now take 1 to 2 seconds. And by the way, cuDF's read speeds is usually on orders at scale, which means about 10,000 to 50,000 rows, is about 15 times faster than reading it in by pandas. Also happy to announce that we will be working with Polar soon. So for those of you who are enjoying the benefits that Polaris brings, you too will just be able to add the GPU engine. And Polaris created that announcement actually, 13 days ago. So this is brand new. And then, of course, we have for NetworkX, we also have QGraph. And what I wanted to share with you is not just with the graphs, not just like, oh my goodness, we're faster, but what the benefits of that are depends on how much you want to delve into using the core libraries, which will give you the fastest speed up, to the CPU acceleration, which will give you a pretty nice and marginalized speed up, not as fast as the core libraries, and then of course normal. So here we have NX, 251 seconds. You can get it up to 30x just by using this import QGraph as NX, CNX. And then, but if you did it completely with QGraph and NX and NetworkX together, you would actually have a 292x speed up. And then you can also see here that, yeah, you might get a 4.7x speed up, but you get a 600 x speed up if you had actually, learned the library. So I really do encourage you to learn the actual and use the actual Rapids libraries. But when in a pinch, when you want to prove something out, please feel free to use a CPU and at least be able to run this through. This is the goal. This is what we want your life to go from and then to, where, hey, normally a lot of you data scientists out there, you know the flow. You're going to come in, you're going to get your workflow started, you're going to realize there's an error, and you're going to have some challenges with that. You're going to fix it, and then you're going to rerun it. Nothing is, or you can do our GPU powered one where you can quickly iterate over time. And I have been spoiled by this because even this morning I was working on one of the notebooks, and I'm actually going to show you the notebook that I was working on. There were some, it hadn't been updated in a few years. And what I'm going to do is I'm actually going to rerun this entirely, this notebook entirely for you. So we're going to shut down the kernel. Hopefully Colab is going to give me enough time. But in Colab, and I'm going to send you a link to this notebook itself so you can run it yourself in the chat. Give me 1 second. There is the actual version, the shared version, and then there's me making edits as I go along. So what I'm going to do is I'm going to runtime. I'm going to run everything after. So from import, and what it's going to do, what this program does is it analyzes from the census data it pulls a 2 gigabyte data set. And in that 2 gigabyte data set, we are going to do some data manipulation, some group buys. We've already read it in. We're actually pretty much almost done, actually. We're going to get the shape of the data, analyze this data frame, clean out our NAs. 1 second. I hit something here. We're going to clean out our NAs. Oh, shoot. It had finished, and then I reset the thing. Let's delete this for a second. We're going to clean out the NAs. We are going to then analyze our D types. We're going to do, we're also then going to normalize our data. And then we are going to run a ridge regression test, and then do our actual get our mean squared errors and our R squared numbers. It says you need access. Give me 1 second. And what's great is I can rerun this again. I'm surprised you need access. I apologize. We shared this one not too long ago. Can you try now? Nice. Okay. So I'm going to go back up to the top. But this notebook normally takes about a good 10 minutes to run on CPU. And as you can see, I'm just going to click run after a third time because I removed the shutoff. And after you've downloaded your data and installed Rapids itself, which takes the most amount of time, the rest of the notebook just runs. And it's already done. Okay. That's that level of iteration where I went from code that was literally 2 years old, fixed all the errors, and changed around the API so that it runs to today's best standards. Took me about an hour, I'd say, on something that would normally, on each iteration, would have taken a very long time and probably the better part of a day. So as you go through and you work on your code and you fix your code and you're looking for, you start to like play with your data, um, this really helps you get that done in a reasonable time frame to where you can go home and have a great day or get it done before your project is due, which for your clients is what you're all about. And like I keep hitting on home, like it's all about that speed and iteration. Um, these are some of the performance metrics that you can get. You know, you could always look these up. But one of the cool things is that because of that speed, we're able to do things like power graph neural networks and be integrated into amazing libraries like DGL and PyG. This allows you to do types of research that were previously unattainable in a reasonable amount of time. And that's kind of what the power of what we're trying to share with you today is that, hey, what can you do if suddenly you were able to move faster, right? Like just think about it like if we were exploring the cosmos and you had, you know, our standard, a car, you wouldn't be able to get very far. But then you have space shuttles. And what happens if we ever get hyperdrive? You can think of at rapids like hyperdrive. Like what can we actually accomplish? And we're actually been pushing the sciences themselves, where in one hour of live coding, we were able to start with some Stanford researchers. We were able to take their entire cancer data set, put it through our libraries, and with the visualization capabilities that come with graphistry and their leadership also coding along us in that 1 hour, we started to show Stanford researchers how cancers first we started identifying unidentifiable cancers, previously unidentified cancers, based upon their metadata. And then 2 days later, they came back and said, hey, this is so awesome. We were actually starting to be able to predict how certain cancers start to transition that we weren't able to before. And that's what I mean by this is giving you a whole new set of fields that you can go and explore and exploit and be first movers on. UML also does this amazing performance, which you also go through, and we also run on Spark. Obviously, and now this is kind of the cool thing that you're going to get from some of these speedups. Some of our clients have been able to reduce their network needs by 95% or their costs by 21 by 20 like 1/20th of the to 20 like 80%, you should say. Why? Well, because if it takes you that much faster to actually process your data, then you don't need as many computers running at the same time. And these clients aren't like, just, medium-sized businesses. We're talking about some of the FANG stocks, if you will. All right. And they've come out and actually said, some of the Fortune 500, they've come out and said, hey, look, this is what happens. And their GTC talks about that for you to see. Because of the way that we are working, we also, and the speeds that we're working at, you also are now able to do things like real-time recommendation engines. We're also being used currently in LLM pre-processing. Like, how do you process the 287 petaflops of data? Well, you're going to need something like us. So when you do things like, some of you are really excited about generative AI and LLMs, well, you have a bunch of data you're going to need and that you need fixing and cleaning. Guess what? You're going to be using us. We also have cybersecurity acceleration thanks to what we've been doing with what used to be Clicks and now is completely NVIDIA Morpheus, where you can do real-time threat analytics, which helps you do better responses to perceived threats. And then, of course, create as you create models from what to do, you can then have systems start to react a lot faster. When we first did this, they thought we were joking around and that we had done it. Nope, just like how you're seeing with the collabs that we are sending you. Um, this is real time. This is just off of the GPU. And the best part is the GPUs that are on your laptops that are NVIDIA GPUs, if they are up till 23012, it could have been like a 10 series GPU. So after that, it needs to be a 20 series GPU or something with what we call a core compute capability of 7 plus. Basically, if you have a newer GPU, you can run this without having to go all the way to the cloud. However, the memory that you require, GPU memory is a thing, and the cloud GPUs tend to have more memory, so you can push more data. Another thing we're using it for is optimization and logistics route planning. CuOpt is a capability using the graphs to actually do real-time optimization. We're reducing people's or our clients' cost in delivery and last mile. You can also use that for your clients, especially on areas around the world where this is not happening. You have an 8 series GPU. I had an 8 series GPU. That's awesome. And then am I actually the GPU in my main laptop was a 9 series. So I was very sad when I joined and I could not actually run the thing I was on. We've upgraded since then, but I still have it. It's a good laptop. The other thing is interacting with your data. One of the big challenges with being a data scientist is that you're thrown all this data and you got like hundreds of millions of rows or thousands of rows. Even at thousands of rows, you're like, what does this mean? Well, we needed to create visualizations help that, but our visualizations are usually static or after like a few hundred points it starts to slow down. Well, we needed to come up with a way where we can do hundreds of millions of points and properly visualize them in a way that is also real time, and we've built it. There is cuCross filter. It is a demo that I want to share with you, but we need to get some. It allows me to do like, well, literally this, but then also like 25 million points and plot things on maps and overlays on different sorts of context bearing documents. And what does that mean for you? It means that when you are actually running through your data, you actually understand what that data represents. And then there are workshops that we created with awesome partners like Plotly, where you can actually create dashboards with tens of thousands of plots. And in that workshop, what we did, and it is open source and available to you, what we did was we took a process that normally took 2 minutes per execution run and turned it into a highly interactive visualization that takes the entire data set and allows you to interact with it in web app speeds, which is 8 seconds or less from desired from the user input for a desired result to then be produced. And then they can still hover over it. They can select. They can do all sorts of things on things like 60,000 to 100,000 different points. All of that on your laptop. And we did that, funny enough, on the cloud. It was over the cloud. So there was actually server latency. It was great. And we gave that for free. Now, what's cool is that Rapids also has a Node.js system library called Node Rapids, and you can then inject that kind of power into your websites. So I've talked a lot and I've shown you a bit, and hopefully some of you were like, we're okay, it installed, and then we ran, and no one's reported any crashing, which means I did a good job in fixing up our code and updating it. So how do I actually use this? Like you said something about a laptop, you said something about maybe I need cloud, like what is it? So some of you just look at the docs. No, I'm kidding. No, so you can learn a lot about us from our documentation. Yeah, they got access. we have a lot of resources to help guide you. In fact, a lot of our notebooks are meant to be learning notebooks, where especially the CUGRAPH notebooks, I literally cut and pasted and read their documents to do some crazy things with airport flight analysis, like over a day. It was about like 2 months worth of great learning in condensed into just reading a notebook, being like, I need that. I want to learn about my communities of my airports and the flights between them. I want that too. And I want that too. To get you quickly up and running with with these algorithms so that you can crush it on your workflows. Okay. So please do check out our Getting Started with Rapids. We have a whole deployment section, and we're going to go through it, and we have community notebooks. But we also have places for you to discuss. We're going to deep dive into them a little bit right now. So for Rapids, there are three main ways to install. You've got pip, so you run the pip packages. In fact, the Collab capability, which is a try it now capability. Please, even though people do their theses on this thing for grad school, which I do not recommend, but you can do it because people do it. It uses, um, you know, try to avoid doing that, because if things don't work out for some reason, because things do change with Collab, um, then some people have gotten stuck at the worst possible times. But if you are, if you when you're willing to pay, this works amazing. If you have your own system, this works amazing. And then it has, all the compatibility with the libraries, especially that are also pip installed. And you just use your VNV, and you just make sure you have your own little environment for Rapids. Another way that you can install it is Conda or Anaconda. You can, oh, yeah, this is all open source. You'll be getting this again. Of these. So with Conda, you can then just do, we have you can install via Conda, and obviously you can install via Docker. There's two places to get it. One is NGC, which is as a member of the NVIDIA developer community, you get access to NGC containers, which gives you all sorts of amazing containers, including my personal favorite, the deep learning frameworks container, which includes Rapids, but also things like PyTorch or TensorFlow, and you basically have your entire pipeline pre-installed for you and ready to go. So you just walk in and just volumize a folder, add in your code, and have a great time. But you definitely, whatever you're using, you're definitely going to need a CUDA compatible GPU. Now, there's a lot of questions. Oh, there's a good one right there. The answer to that one is absolutely. And we have a pip install. We have not a pip install. We have an installation guide just for WSL where you can use pip, Conda, or Docker if you so choose. So you have to be running Windows 11 as well as have WSL2 and have your NVIDIA GPU. Mauricio, thank you for that question. Now let's assume that you got, yep, we're on Mamba will install over Conda Forge. Okay. The channels that we are at are Conda Forge. Thank you for that question, Nicole. So now let's assume you don't have a system that is local and you need something on the cloud. Okay, well, don't worry, we got you here. We have entire deployment docs that are highly detailed that will get you up and running. And in fact, oh my goodness, let's look at all the cloud, at least for the top three that you can get and what GPUs are compatible. Well, as you know, Pascal is being retired at the moment, but you have T4s, V100s, A10s, A100s, L4s, and H100s. Those are the GPUs that are available to you, but you can pick from AWS, from Google Cloud, or Azure, whatever you or your client needs, and have their stack on, and they're running. You can pick one of these instances here, or as you know, at Google Cloud, you kind of have to connect it, and then you can scale out with everything from just a single node to multi-node to multi GPU to multi-node multi GPU. You can use Kubernetes, you can use DAS, you can use HPO with SageMaker, which HPO. Sorry. Now that's amazing. That's a lot. Touring like that is, I have to remember Conda installations and make sure that everything works out. And then we've got these deployment guides. Well, never fear. We started something very new. In fact, it is so new that it's probably going to be released in the next couple of weeks. So this is one of those great things I get to do, which is to share with you the upcoming that is actually here that we have announced. So there are two different NVIDIA installation capabilities, one called SDK Manager and one called AI Workbench. And AI Workbench and SDK Manager, both of these, Rapids is one of the first libraries that is available on these. Like these are, so we'd love for you to beta test and check things out. Well, not beta test, they're actually in real, but like just check things out, tell us what's going on, try it out. We love feedback, especially from active developers. But the way these are different is that SDK Manager is great for deploying on your system, your personal system, and makes it super easy. So like, let's say you're not used to running on Ubuntu Linux because Rapids requires Ubuntu. So you have WSL2. Well, some people don't know all the commands and maybe they want to have different options and different installation options. Well, SDK Manager it gives you a graphical user interface so you too can just quickly get through and install Rapids. This is upcoming within the next week or so. We will let y'all know when that is fully released and you're able to partake. The other one is more of a, hey, I've got multiple different tools, multiple containers, multiple capabilities, and I want to work either on-prem, hybrid, or completely in the cloud. And when you do use AI Workbench, it allows you to deploy your code anywhere and everywhere. Now, this is where that whole CPU analog, the CPU compatibility layer comes into play, because now that means that you can write your code on your laptop, and by adding in the line that loads in our libraries, when you deploy to your GPU cloud or your GPU resources, it would immediately speed up that. So you can debug and test on your laptop if you can, and then deploy at scale on GPU, or test on your GPU, local GPU, and deploy at scale on cloud GPUs. Now, what's cool about that is as you have like things like AI Workbench, you can now take advantage of over 100 different integrations. Like I said, Polars, PyG, like this is not everything. We have so many others, but now you're able to really take advantage of your entire end-to-end workflow and accelerate that. So at this point, I'm going to pause because we're almost done. And I'm going to just give everybody a moment to breathe and just think about some questions here. Some of you have either running the code and you're probably going to like see what the results are. Some of you are just thinking about it. There's a lot of information. So as you think of the questions, I'm just going to tell you some key tips. Okay. As always, we are recorded, so it'll be good times. So first one, Rapids GitHub. This is where you find our source code. It is out there. It is open. It includes our notebooks. You can pull things down. It's great. You can ask questions. You can, ask questions, create issues on any bugs you find. We're usually very responsive. Request features. Maybe there's certain things that you need. You can even ask. And everybody who responds is usually, most people who respond are engineers actually on Rapids. ask you to please, as you explore, go to our docs. Sometimes we get questions like, hey, does this API support it? And we'll be like, but the docs are right there. You just like search it and it'll tell you. And or how. So please go to the docs. We keep those updated, especially per release. You can go back one release and you can go and even check out our nightlies. But most of our stuff is there, and that is at docs.rapidsai.com. We've got a lot of blogs, especially on Medium. And I run this repo called Notebooks Contrib, where people like you have contributed notebooks for workflows. Sometimes I externally link, sometimes there's stuff that's in there. But what this is more of an area where if Rapids this is the core libraries, and these are notebooks that work with each library, this is where you get real world examples. In fact, that census notebook one that I sent over there, that one is from that library and that repo. And that's about, and I should add in, we have a Slack channel, the Rapid Slack channel, which I will come to here. If you go to rapids.ai and Slack/invite, you will then be dropped in to where the previous cohort also joined us. And there you get a lot of good questions and answers in almost live. Some cases, as soon as we see it, we start working on it, and then we try and give you a great answer here. So, in fact, I'm just going to show it to you. Probably somebody has answered a question while I was here, and no one did. But as you can see here, we're here and we respond really, really, really quickly. Okay, so I do invite you to join us on this, as well as the NVIDIA forums. And then, of course, if you ask any questions on Stack Overflow, we find it, we will answer it there as well. Okay, so with that, I pause. Any questions?
Hi, Torin.
Yeah.
It's JB, right? Yeah, I have one question. So actually means I was working on one use case where I was training one YOLO model. So basically means I'm playing with the image data and doing the training on YOLO V7 version. So training the model on YOLO V7 was taking around more than 10 hours of time with GPU, Azure GPU, Tesla T4. So
Okay.
can we still means speed up that model? Like means I was training on the 100 epochs. I was just using the Tesla T4, but not integrated with Rapid or any other things there.
So Rapids is on a different side of the ML spectrum, AI ML spectrum. So we've got tabular data, and we've got some image data where we can do some sort of manipulation of that data with cuSIM, which might help you. And then we get back to some of our deep learning systems, which are based on some of them are based on neural networks, right?
Yes, yes.
So Rapids and then after that, you've got your post processing where you're trying to see the goodness of your model and understand, right, when you do your testing and confirmation, right? So Rapids will help you at the beginning. cuSIM, which is part of Rapids, might help you in the middle, but then Rapids again will help you at the end. And there's a great blog by some of the Kaggler's where they show like, oh my goodness, trying to understand like the goodness of my model, and it's telling me in seconds versus a few minutes, or a few, and now I'm able to know and I get to train. So that's number one. Number two is you're using a T4, which is a very old GPU at this point. I promise you, if you jump up to a one of our friends, Paperspace, even though it costs a little bit, has A6000s and even a single A100 GPU. I would really recommend that because when I was doing a Kaggle with a V100, even though it was, one generation above the T4, people were just astounded by this stupid amount of speed. Okay. So you could
So, so
probably bring that down just by upgrading. So let's go to that for a second. Your T4 is 8.1 and you're starting to hit, you can see the differences as it goes through. And that's just on floating point 32. You drop it to 16 or anything like that, you'll be good.
okay. Yeah. So thank you. Means I will try to upgrade my instance.
Yeah. Pick one of these, please. Like, usually we go for the cheapest, but sometimes when it's time to get, that's great for training and testing, but when it's time to get to work, go big. Trust me, you'll be so much happier. All right. We got one online, understanding performance. Okay. And we'll, we'll get to you in a second. My question is, does this laptop brand, which laptop brand? I don't, you will need an NVIDIA GPU. And even though I'm going to start to understand a little bit more. Um, One of the things that I found, and I worked with a developer on one of our community members on, was the use of eGPUs on laptops. Certain laptop companies may not, or certain hardware companies may not like the fact that you have an NVIDIA GPU on them, and they may not allow you to boot. However, most other, like every other laptop manufacturer will. So if you have it in certain laptop manufacturers, please don't put an NVIDIA GPU on there. You would have to only boot into Linux as the operating system, and any other sorts of going back could be, I wouldn't say problematic, but like as soon as you disconnect the GPU, it's all back to normals. How could I know that my local GPU can run my local laptop can run GPU processing? It would say it has an NVIDIA GPU on there. You can go into Device Manager and look at your display driver. I think it's also in System, or into your About. Now, yeah, I am going to see which of the collabs that might be happening in. Can you send me an output of the error itself? And if anyone else has any other questions, please do let me know. Nice. Yeah. So you've got a RTX 3000, which is pretty awesome. All right, and you have shared GPU memory of 0.1 gigabytes. So good times. You are going to have a great time at Rapids. So if you are looking, let's start to answer some of these questions by actually going to the docs. And no, that wasn't meant to be condescending. It literally is. We're going to walk you through how. So we have this Rapids installation guide. And to make life easy, you literally have this interactive diagram that spits out the exact installation code that you want. You copy this, good times. You want stable, look at how different it is. Copy that in, paste it in, good times. Conda, copy it in. This is if you have Anaconda. If you have Mini Conda, you're going to need to install Mamba and remove the solver libmamba. Okay. If you want Docker, you've got NGC or you have Docker Hub. Good times. You just copy this and go. Now, in here, we have system requirements. And in system requirements, we have this thing called compute compatibility. Now, if you click compute compatibility, you're going to be taken to this awesome page that actually tells you a little bit about every GPU in terms that you probably have never even seen. And one of those is the compute compatibility. So you can actually look up by, if you got data center products, let's look at your Quadrant RTX. I think one of you had an MX 250, right? But the M part is what is cluing me in that is probably a Maxwell GPU. And because it's Maxwell, may not be able, it should not be able to run Rapid, sadly. I don't know where the 250 is. I thought it was on, it should have been under Quadro, but I did not see it. So sadness. Okay. Um, as we go through, oh, it's a GeForce. Sorry. It should be in here, and it should still be in. Still not seeing it, but I'm also going fast and live, and we're recorded. So that's one. Now the other thing is somebody asked about WSL2. Here it is. We have a specific installation. This will run you through it. Hey, it still runs. Good times, man. I'm not faulting. But the core idea is this: it must be higher than 7 to run latest rapids, or 6 to run rapids at all. Any version, any older version. Now, people are asking me, no, it is so rapids. Let's go back to an area that I kind of glazed over, mostly because it kind of mainly because I didn't know if you even a lot of you want to understand this part, but um, so here's how rapids works. There is this middleware library on all GPUs that convert the type of processing that GPUs do into general compute that we call CUDA. It is the base level of everything that allows NVIDIA to do all the cool things that we now are able to take advantage of today. Because of that, only CUDA enabled GPUs, right? And CUDA, sorry, I should say it's general compute. It basically makes it so you can program it just like a regular computer a CPU based system. Because as you know or may know, you we have just settled on paradigms based upon popularity, and the x86 architecture or CPU based programming kind of was that popular way. So everything kind of had to fall into that. So by using CUDA and allowing us to do things like that, we were then able to build a few layers of extraction. So Rapids takes care of things like your memory. It takes care of your and memory management. It takes care of parallelization. It takes care of a lot under the hood, just allowing you to use your normal APIs and not having to make you become an amazing CUDA developer as you do your data science. So things like AMD's Radeon or any of those, they don't take advantage of that. I would tell you, you'd probably have to provision a new CPU either through getting an NVIDIA one and putting it into your machine if you can, or you can get a cloud instance. And what is cool about having multiple NVIDIA GPUs is that, or having a single GPU, is that you can use a server instance to use things like data shader, especially for visualization, where you can run these. If you have things like an A100, we didn't really get into like the awesome specifications of some of these GPUs, but you can actually partition an A100 into multiple. So if one of your clients happens to have one and you just don't happen to have access, you can actually break up that GPU, share it amongst yourselves. Especially if the 80 gig ones. Those are awesome. Or the and that went on to the H100s and they will go on to Blackwell. Any other questions? Right. Okay, so Ali asks, thank you, by the way. I know it was a rough start. Really apologize for that. I had a long night. um, the AI tools. I want you. So yes, actually, let me give you this. So Ali's question is basically like, how do I like what tools can I use to up my level uh, of Python proficiency, and so that way she can they can get their readiness up. Um, Believe it or not, we do have some of that information. I do have some of that information here because I get to, that's part of what I get to do. So I'm going to copy this. I don't know if this was sent to you, but if it wasn't, allow me. So I have one of the things that's in Notebooks Contrib is a crash course on Rapids. Another thing that I really only share during sessions like these is that getting started. So if you don't know I'm sorry, wow, that came out right. If you don't know Python, I suggest W3 Schools. It's a great way of getting started, of really getting your hands dirty and, understanding the fundamentals of how the Python programming the scripting language and the syntaxes that it uses. It also has a pandas course. And then you have things like Coursera. When you want to understand things like machine learning, you I like to use there's a guy named Josh Streamer, he's StatQuest, and it is pretty awesome. It is not the most exciting in terms of course content, and but he makes it understandable at a level that like it's like, are you smarter than the fifth grader? Probably not if that fifth grader has watched StatQuest. So please do like subscribe to his channel. It's a pretty good one. No, he does not get anything, nor do I get anything from him. I just really enjoy it. In fact, I was reviewing one of his things for Transformers, and though it's a 45-minute long session versus his fives, it was understandable. It was really understandable. Sarah? And then, of course, to your BI question, the Plotly, the data shader, the Q-cross filter. Oh my goodness. There is so much there for business intelligence. In fact, the last sessions that we had for the Andela crew, a few of you made business intelligence applications where you were doing cell tower analysis and doing spatial analysis and visualizing it on maps in real time where you're able to play with and do massive group bys and other things. So yeah, the difference between like Tableau or Microsoft BI or Excel, where where it takes like minutes to load something, you would be playing with your data and then reshuffling things at like on 25 million points. And I wish I had known that you had some interest because I would have just happily done the New York Taxi demo with 25 million points. And you'd been like, oh, yeah, that's cool. In fact, see if I can start that. And I know we're over time, so that's kind of why I'm pausing right now and saying like, if does anyone have any other questions that I can answer, because I'm trying not to spend too much time on one topic, especially for debugging. Oh no, wait, we have 15 more minutes. Ah, sweet. Thank you, Ibrahim. did make it to 90 minutes. You know me too well. He was like, yes, we talked about it, Tori, and you take a long time. I did try and
No,
shorten it this
Torian, you
time.
did fantastic. It was very, very succinct and very hands-on, and I think the examples were great. But yeah, would love to hear from the others on the call. What uh, takeaways that you guys had? Feel free to unmute yourself, or you can share it in the chat.
Other questions you have are deployment questions. Does anybody want me to go over some of those capabilities and where to find them? Because it sounds like a lot of people are like, hey, wow, I don't have a GPU for this. And that's not an insurmountable challenge. You just click deployment guides, like right here. And then you have your local machine. You have clouds. You could pick your cloud. You can do
Hi,
Slurm.
Eno. Torian, I think we have a question from Eno. Feel free to unmute yourself and share your question with us.
Yeah, I was trying to run the application online. I was one that got some errors.
Yeah, you got the type
Basically,
error.
yeah, I'm sure it has to do with the code. Let me rephrase that question because
Could,
maybe something needs to be
could
fixed
you
on
tell
that.
me which one you were running?
Rapid Curve Pandas Accelerator mode
Okay,
on
and
the
which cell?
profiling functionality. I actually copied it to my own Google Drive. I don't know if that's an issue. I copied it to my Google Drives and told it to run all. And a couple of things were failing at different points, but the one I couldn't go beyond was when I was trying to do the profiling functionality, and it kept saying it couldn't. That type error was so there. Um,
So let's go back.
maybe
Give me 1 second. I'm gonna actually spin up an instance right now. And we will see. So this one's on me because when we just did this, actually I'll just do it here just because it is. Oh, good, I'm disconnected. Let's hope that I still have some collab time because I, like you, use collab on the free side. Yeah. So so this is the version of the code that actually runs locally. So what I'm going to do is I'm going to download this. All right, I already have it. And I'm going to open up on my side one of my machines that I have running. Okay. Hey, Abraham, do you mind stopping recording just because I've got to show an IP address I don't really want to show off?
Okay, no problem.
Thank you. Sweet. Let me know when you're done.
Yeah, done.